Making a video. Think so anyway. Might be something like a video. So anyway, I'll start with a comment, but mostly go to some crap I thought of. Stuff. Gotta fix my language. Now my language is probably just gonna get worse and worse. Anyway. So I'll get to this other stupid comment later, but I'll get to this one first. So stay on my agenda. Much enjoying your videos. Hopefully things better soon. You might already know Linux-based recovery tool. Yeah, well, the problem with the Linux-based ones, this was actually a recovery tool. The the little version of Linux I'm using, Knoppix, and yeah, it didn't work on the computer that needs it. So that's the funny. I couldn't even find the hard drives. I mean, you know, not a great tool, but it has some hope of working on the other computer. So we'll see how it goes. But yeah, the recovery tools can force you to need a recovery tool. That's how I ended up killing the hard drive, was playing around with the damn recovery tools. Anyway, so back to the subject. I'd much prefer the concept of saying each force bit has a mass of 1, whatever unit that would be. Like you said, mass of 0 doesn't make sense. Laughing type face, I guess, or something. Anyway, yeah, so it is a real problem with this language of these words we're using and how to quantify the difference between this weight idea, mass idea, and then this key thing of momentum in the context of velocity and acceleration. So I think I have come up with a way around that. It's just some art video. That's a little art cube thing. See some of my artwork. We can go there later, maybe. Yeah, I used to. I used to be an artist. I just don't have time for that shit anymore. So I have to do this stupid physics crap because everybody's a moron. Alright, so I came up with some definitions here that I think are going to be more useful in the future. People might get to, might have, as long as we have common verbs, you know, words and verbs, we might have some hope here. So, mass is the ability to exchange trapped, possessed momentum. So if you understand that when something has momentum, it got it from something else. So if we could all agree that there has to be a force that acts on something, like Newton said, and for it to have an inertial bit of velocity going somewhere. If it's going somewhere because something forced it to. And by forced means it actually put force into it, momentum. And the momentum is a kind of real thing. Yeah, which I'll say in the next sentence. So the idea is that it already has something, all right, and it can exchange what it has. So if it has a lot of stuff going in one direction, it can give back a lot of stuff in that direction, in the sense it can let that loose and stop moving. So if it hits a brick wall, for example, it can let a bunch of this force stuff loose, smash into the bricks, make them fly apart, do things, and release the momentum, exchange it for momentum going the other way to balance itself. So now it's all balanced again. So it exchanged a bunch of stuff going this way for stuff going this way, and now it doesn't have to move anymore. Yeah, so it's really holding on to half the momentum it might have in this direction and just balances it with another half going this way if it had a huge imbalance. Yeah, so it would stop moving when it has an equal amount in the two sub-dimensions of one of the three dimensions. So it's always a dimensional issue. Up, down, left, right, forward, back. Yeah. So yeah, so I might have to draw it, but you know, mass is the ability to exchange. So it's an exchange you're making. You have stuff, you're going to trade it. So something going this way is going to give you stuff going this way, and in exchange you're going to give him something going that way. That's the exchanging. Alright. Elemental momentum is in the form of a force bit or standard force corpuscle, using Feynman and Newton's language. So it's just understand that it's just a standard clump, a Planck amount of this momentum stuff. Alright, and that's what these things are exchanging when they have mass. So when they have mass, it just means they have an amount of stuff to exchange. they have money. Okay, so if you thought about it as pennies, they have pennies, and they can exchange them. You know, pennies, you could say, that have arrows on them pointing in a direction, and they're just basically going to exchange. You can make certain kinds of exchanges. You can't exchange an arrow this way for an arrow this way. Stupid exchange, don't bother. But you can exchange an arrow this way for an arrow this way. So if you have a penny that has an arrow going this way on it, you can exchange it for an arrow going that way with somebody else, with something else. So that's all you're really doing, is just exchanging these little bits of momentum, or you could call it money. Yeah, you could. And what you possess, you know, when you've done your exchanging, if whatever imbalances you have, that's the direction you're going to move in. All right. Traveling the speed of light, or more precisely the speed of force. Let's understand that that probably should be the right way to say this. We shouldn't really be thinking of light as the standard of something moving this speed. All forces move this speed. Magnetism, gravity, light. The current inside of a wire is essentially, if free, electricity would be moving the same speed. It's just only slowed down because it has to go through the wire, and the wire's a little bit dirty. So if you can clean the wire completely, it'll zoom right through it at the speed of light. Alright, elemental momentum comes in two types, positive and negative, or more exactly, electron reflective force and proton reflective force. So that's just thrown in there to point out that the whole way this whole thing really works, the charge and the magnetism, is because there are two forces. There are two types of money. There's pennies and nickels, let's say. Let's say there's aluminum pennies and copper pennies. Alright, so there's pennies that have a direction on them. All of them have an arrow, and they can either be made out of copper or they can be made out of aluminum. Now, if they're made out of aluminum, then they bounce off of protons, and if they're made out of copper, they bounce off of electrons. They do a few other little things, but those are the fundamental functions. So you think of an electron as being made out of copper, all of its pennies, all of it, the momentum an electron holds, the mass it has, the money it has in its vault. So an electron has money in its vault, a certain amount, and all of it is in copper. And it can only exchange copper for copper. And the proton has all of its money in aluminum. And it can only exchange aluminum for aluminum. Exchanging in terms of doing the momentum thing. I'll give you one going this way, you give me one going that way. So that's what I mean by exchange. That's when momentum is changed. It's very hard for your momentum not to change. If you gave away one going this way and you take one going this way, it's quite obviously going to change your momentum. Or this way and this way, or this way and this way, right? So you can make exchanges in any of the three dimensions, and obviously the three dimensions are any which way you happen to be oriented. But anyway, yeah, so once you do this, once you understand that charge isn't just about electrons and protons, it's about the force, and the force is likewise electron force and proton force. And that gives you all kinds of capacity to create the interactions you see with magnetism and electricity. Okay, so back to the less interesting subject of momentum. I mean, it's less without the complication of the aluminum and copper. Anyway, so velocity, so there's a word used, is the byproduct of a dimensional imbalance. So you have too much forward, less back. You have more right than you have left, you have more up than you have down, then you're going to have a velocity. In the direction of trapped possessed momentum. So that is, you just have more pennies going with arrows going up than you have pennies with arrows going down. That means you're going to have momentum in that vector. Now you could also have more pennies going right than you have left, and then you'll have some momentum in that vector. Then you just add the vectors, and that'll be your velocity. I.e. more forward than back. So I'm just giving you an example of forward, back, up, down, left, right. Acceleration is the process of exchanging corpuscles of momentum. So that's all you that's all you're doing. You're exchanging them. So mass is the ability to exchange. Acceleration is the process of exchanging. So while you're exchanging, okay, that's when all this crap is happening. All these exchanges are happening, and it's a little bit uncomfortable for the matter because exchanging is a process, and it has to, you know, the tellers have to do work, whatever, how you want to think about it. It's a task, and that task means you're now multitasking because it's a new task, right? Your system was all happy, just the way it was. My bank pieces are all where I want them. Everything's just fine. Everything's comfortable. And now we're going to jiggle things up and start doing exchanges. Now that takes time. That's the time dilation component. You're now wasting time exchanging money instead of going the direction your arrows are pointing. So now you're now being distracted from whatever the process was that was, I'm an electron, I'm in an environment, and now I'm getting hit by other extra requests for exchanges, and the more requests for exchanges happening to me, the less it slows me down. I can only make one exchange at a time, so to speak. So you say, if there's an exchange window and you have to turn your window to whoever wants to make an exchange, if you have to make more exchanges, then your ability to make exchanges, say if I'm making exchanges left and right, and they're coming one a second, and I'm making these exchanges, and then somebody starts saying I have to do exchanges up and down. Well, obviously I can't do my left and right exchanges at the same speed if I have to do up and down exchanges, that kind of thing. Time dilation is just multitasking, and the more tasks you have, the less efficiently you do the task you're doing. And if one of the tasks you're doing is counting time, you're not going to count it as fast, simply put. Alright, so I think this is a good start. I think that was a decent enough explanation. Maybe we just go through it one more time. Alright, so mass is the ability to exchange trapped / possessed momentum. So that means the boat analogy. There's no real boat, okay, but we're just going to use a boat just so we have somebody to put in the boat, and that's the momentum. So an electron, let's say, because of it has a mass number. So let's say its mass is 1,000. We'll just give it a number. That means it has 1,000 momentums in it. That's how many it has to exchange. And what you're going to do if you throw some momentums at it and a little bit of extra force. Oh, cool! It froze. Oh no, it didn't freeze. Okay, sorry. Screensaver. It does this once a day somewhere. It'll just crash. You know, which is really irritating. But it hasn't done it to a video yet. So at least that's some hope. Alright, well anyway. Alright, so mass is the ability to exchange trapped possessed momentum. So you have a boat, and the bolt is just the vault that holds the momentum. You could look at it that way. The idea is that something's now going to make more exchanges coming from one direction than the other direction. And so now I'm going to lose a couple of momentums that way and collect a couple going that way. And now my overall mass is going to have a little bit extra going this way. Now it's not going to move me the speed of light because I still have a bunch of other momentums going all kinds of other directions. So who knows what my real balance is. But it will make a difference. And it certainly makes a difference to electrons. But you know, who knows what the exact, I don't know what the exact number would be. 1,000 is just a guess. And then you could say the proton is a heavier, bigger, more mass, so you know it takes more exchanges to have an effect on its momentum. It's the difference requires you to change more of its mass, and that's what gravity does. Gravity changes you based on how much mass you have, how much stuff you have available for exchange. It knows how many you have essentially, as it's going to go right through them and hit them, so it knows what's there, so to speak. And if you're a feather, there's very little to exchange. You only got 10 pennies. If I'm a piece of lead, I got 1,000 pennies. And it's going to make the commensurate number of exchanges based on how many pennies, simply, by a percentage. And so you'll change the feather. You're only changing 3 momentums with the feather. You've got to change 300 with the lead to move them at the same speed. But again, nobody has to really do the calculating because the force actually does the exchanging. It can't miss, knowing what your volt has in it, your mass volt. All right, how else to say it? So we don't have to give the momentum. Okay, it doesn't have to have mass if we understand that mass is really the ability to make an exchange. But in a sense, the ability to make an exchange is the pennies. Without the pennies, you can't make an exchange. You wouldn't have any mass. So clearly, in a sense, the pennies have to have a mass of 1. Just no point in doing it any other way. The momentum bits, the corpuscles of momentum, have to have a 1 value. Alright, anyway, so elemental momentum is in the form of a force bit, or standard force corpuscle. So that means if it's light, it's at a frequency. If it's gravity, no frequency, and it's mixed. Gravity is aluminum and copper, all mixed, coming through. Magnetism, or charge, means that you have created an element that only reacts, the reflective, that only does exchanges with copper, that would be the electron, or one that only does exchanges with aluminum, that would be the proton. So that is, the aluminum bits sort of bounce off the proton, and the copper bits are diverted 90 degrees, perpendicular, one of the perpendicular dimensions. But anyway, that just gets a little more complicated. I'm just saying the reflection part is the key part, because that explains why 2 electrons repel each other. It's because they're reflecting the copper bit back and forth, back and forth. You see, the copper goes in, the exchange is made for one going this way, okay, for one going this way. So when this one goes in, the electron says, oh, I move a little. And when this one goes out, that's essentially what it's saying, I move a little, right? But this one came out, which means it's going to hit this one, which is going to say this one wants to move a little, because it's going to let go of this. It's going to keep this direction. It's going to throw back this direction. So its overall momentum will change and it'll move apart. So that's the reflective part. And the more reflections you have, the more pressure there is for the electrons to move away from each other. And the less pressure you have, you know, they would move in towards each other, but that can't happen because it's all reflections. All right. But clearly, when the electron and proton are next to each other, you can understand that the electron is throwing copper. Copper doesn't mean anything to the proton. Can't gain any momentum from copper. And the proton is throwing aluminum. Aluminum can't mean anything to an electron, so it just leaves perpendicularly, no momentum. So they can't be moved by those. So no pressure is being created, no reflections. When it throws copper, copper leaves. When this one throws aluminum, aluminum leaves. There's no back and forth, there's no reflection, there's no pressure. So they move into each other. Because there's no exchange pressure. They're not exchanging money they can exchange. It's Canadian American. You know, and the banks, they're just saying, fuck you, I'm not taking that garbage. So they can't, there's no exchange rate. They can't exchange. So it's like, yeah, it might be a good thing to, it's like Americans are lean, mean electron money. And Canadians are fat, lazy, clumpy protons. Yeah. That might be a good metaphor. Alright. Where was I? Corpuscle, traveling the speed of light. Now, like I said, more precisely, more accurately, let's be modern and grown up, and let's realize that the speed of light was just a term used because they discovered light first. And it's not the speed of light, it's the speed of all the forces. All the stuff going, the speed of light, okay, is a force. And all of those forces are going the speed of force, not the speed of light. Okay. Elemental momentum comes in 2 types, positive and negative. So again, just getting to the point that it's copper or aluminum, it's electron, proton, it's Canadian, it's American, however you want to look at it. It has 2 distinct quality differences, and those 2 differences in that force is the same thing as the difference created. That's how the 2 the electron and proton are different. It's because they're throwing different forces. They're reflecting different. They're exchanging different. and that creates magnetism, and it's all explained with that simple. Without those two forces, that's why they see, if you don't realize there's two types of force, you'll never get the right answer. Okay, so physics is hopelessly broken until first they recognize that gravity is a force and that magnetism is a force and that electricity is force. Until they realize that, and then realize so that's the first thing they got to do, is get to the speed of force thing. But even if they do that, until they recognize that there's two kinds of force, they're never going to have the right answer, because that's the right answer. Everything falls into place. You have two forces, the whole thing falls into place. You can explain attraction and repulsion then. You can't do it any other way rationally. You just end up with a bunch of this swirly, hyperboloidy, toroidy, uppity-downy, bullshitty stuff that doesn't make any sense at all. Nothing flies like that. Not even the drunkest UFO. So anyway, reflective force and proton reflective force. So I think I said that part. Let's say it again. Elemental momentum comes in two types: positive and negative, north, south, electron, proton, how else can blue, red, Canadian, American, or more exactly electron reflective force and proton reflective force. The reflection is the key thing. Like I said, that creates the repulsion. But it is very important also to understand that when a piece of copper goes into that Canadian bank, they just chuck it. Okay, they will not exchange. They'll just chuck it out the window. And the same thing for the American bank. You bring in that Canadian crap and they just chuck it out the window. Yeah, it's a good metaphor. All right, so do velocity again. Velocity is the byproduct of a dimensional imbalance in the direction of trapped possessed momentum. So it just means that you have a bunch of pennies, and if you're standing still, it means all your pennies, you got just as many going up as you have down, just as many left, right, just as many forward, back. But if you're moving, it means somewhere you have an imbalance. And the imbalance is usually going to be in a multiple of 2, in the sense that you'll have 10 going forward and 8 going backwards, because of the exchange idea. The idea that when you take one in, you give one away. So it's always going to be like a 2 for imbalance. Like say you had 9 and 9, and I take one in. Well, now I'm going to have 10, but now I'm only going to have 8 going the other way because I have to give the other one back. So it's always going to be a 2 for exchange, which is perfectly consistent with the mathematical what we see in the world. Okay. Now, more forward than back. Yeah, that's so simple. And then acceleration, which probably should be first before velocity, but you know, whatever, is the process of exchanging corpuscles of momentum. So it's just the simple mechanism of the fact that acceleration is when you're getting hit by the run on the bankers. You know, the people. You know, you're getting hit by more momentums are coming one way, saying exchange me, exchange me. So it's like more force. Somebody shoots a laser beam, and the laser beam is basically saying I'm more stuff now, and I want to make exchanges with you. And there's no laser beam over here, so there's nobody making exchanges for this direction. So you're just getting hit by arrows going this way. You have to make your exchanges, send a bunch of arrows going that way. You're going to move this way because you're not going to be able to make any extra exchanges going the other way. So you're going to go that way. You're going to be moved. You're going to now have more momentum pennies in that direction. And that's all there is to it. The idea of the reason why velocities get difficult, you know, to go faster than light, you can sort of understand that once all my pennies are going in one direction, yeah, I'm done, right? I'm now a laser beam. You know, I'm not matter anymore. I can't possibly be matter anymore because everything I got is going one way. There's no room for mass in any other directions because I've got them all in one subdimension. So, you know, there's 6 subdimensions. I have all of them pointing one way, then I'm a force. I'm not matter anymore, I'm a force. So the minute you exchange everything is the minute you probably aren't matter anymore. But you could never get to that point. You could sort of understand. Because let's say I exchanged, you know, 90% of my money. And so I've got 9 going this way and only 1 going this way. You can sort of understand that if a new force comes in trying to hit and make exchanges, it's going to have a hard time hitting because it's only 1 going the right way. So it's not going to be able to get to the window that actually has the money going this way. It's going to keep hitting windows that don't have no this way, so it can't make an exchange. There's no money in the drawer. It can't make an exchange that way. So it gets harder and harder to hit the bit that's out of alignment. The window that has the bit going the right way gets harder and harder to hit the faster and faster you're going. That's why it's hard to give things more and more velocity. As velocity increases, they get heavier. So they're really not getting heavier. They're just getting harder and harder to push. Yeah. Alright. So, yeah, so that's probably enough. I don't know if I need to draw it. I guess I could try it, but it's so, it's just this, like I said, just think of it not as a boat, but I mean, just think of the electron as, like I said, it's all just copper money. And the proton would be, where's my red pen? And the proton would be all aluminum money, you do that in red. And it's just they're stuck with it. Once you have it, you have it. That's their standard mass. They're sort of made out of a certain amount of this stuff. So we know that the average electron is always the same mass, and the average proton is always the same mass. So it's the way they were built inside of the sun. They have a certain amount, and that's the amount that makes them stable. And so what's, like I said, the simple rule is that you have this idea that it's a boat. These are paddlers in the sense that they will make you go in a direction, but they're just pennies with a direction. You could just say just arrows, just pieces of momentum. And the environment comes in with stuff coming in, going, say, this way. How can I get backwards? I have to fix that, damn it. It just makes my life more... Now I can't write anything, so if I write something, it's backwards, right? Yeah, that's backwards. Stupid damn thing. I mean, it's, I was clever enough to get these to work in the browser window, which is kind of nice, but you do have to fiddle with it. I'm just sick of I'm sick of having to fiddle with everything. I just wish there was some off-the-shelf crap that actually worked and I didn't have to keep doing this myself. Like drawing, I shouldn't be drawing. I gotta get a better camera angle. Gotta work on that too. So anyway, so this stuff comes in, and obviously it's the right kind of stuff, so it'll make the exchanges, and so it will give away 2 of them going this way, and that's extra over the standard amount of force. Like I say, everything's getting hit by force all the time. We're just talking about extra bits of force. So if there's an extra bit in this direction, then this exchange will take place, and now this thing will end up having an imbalance in a direction because it gave away that and it took in this. So you're just talking about stuff going in and stuff going out. So essentially the mass of the electron stays the same and the mass of the proton always stays the same, and they just make exchanges. And that's all that really happens. And so they're the real catalysts. Without them, there's no mass. Nothing has any mass. They're the things that are really holding the mass. And you could argue you collect a little extra mass by having extra little bits in between. Say if your electrons, you have 2 electrons, you can have a bunch of extra bits trapped between them. And so you could add a little bit of mass that way. But I think in the real game, the real mass is the mass trapped in the electrons themselves. Is a lot more mass than what's trapped between them. A lot more momentum in the boat than swimming between the electrons. But all the momentum is mass, so you have to count it all. It all is part of the equation. That's why they say, like, when something is accelerated or give it velocity, it has a little bit of a mass gain. Well, some of that could be the fact that like in a battery, for example, if the battery is collecting the mass by expanding the atoms, you could sort of understand that expanding the atoms would mean that you put more force between the electrons, and therefore you've collected more mass. But it also could be done just by changing the momentum of the electrons, that is, having them turn. So some chemistry would require you to collect the mass by collecting the mass between the electrons, and then some chemistry would be because you gave the electrons momentum and they're moving. So depending on how you're trapping the momentum, you could see an increase in the overall mass of, say, a battery. So some batteries will gain mass, some batteries won't. Depends on how they're collecting the momentum, whether they're moving the electrons inside the atoms, or whether they're just putting more pressure between the electrons. But that's a much deeper subject, much more complicated. Don't want to get too complicated. So anyway, I should do some on magnetism just to point out how this explains magnetism perfectly, but I don't know. You should be able to see the monopole, plus, minus, North Pole, South Pole. I mean, clearly this is the, and so all you're saying is when you have the two poles stuck to each other, you have a magnet. When the two poles are separated, you have charge. It really is that simple. Alright, so let's see if there's anything else to deal with. Might not be. Some more artsy stuff. I'm going to finish with that maybe. What else do I want to bring up? Yeah, no, that's about it, I think. No point in getting too complicated. Ironically, I did make a lot of clocks. It's a whole relativity thing. Made a lot of clocks. Anyway, this was painted on a shirt. So most of the stuff was painted on shirts, which means it's pretty impressive to have a painting that looks that decent and it's painted on a frickin' sweatshirt. It's not bad. Yeah, that was pretty good. Anyway, so yeah, so this is important stuff. So I think this is a good clarification. I think it's if people take a little time to really focus on the words here, they can get it. This really is all you need. Like I said, once you have this and you have this idea of the electron, the proton, the reflective forces, then you're right next to charge. You're almost at the definition of charge right there. And once you have charge, then you make dipoles out of the charge and you have magnetism, and then you're almost done. You have a little bit of subject left of current, voltage and current. But like I said, that's just as obvious almost as it all just falls in place as the magnet idea. That's just the movement, and current is how many atoms you're involving in the movement, and voltage is how much pressure each atom is transferring. And it's just so simple. How many pennies? I come to the bank with 500 pennies. All right, that's high voltage. So those exchanges, I dump 500 on the counter. We do it real quick. It's a real quick transition. But if I spread over a whole bunch of atoms and just do a penny at a time, well, then the current's high, but the voltage is low. Exactly how it's been. That's a perfect metaphor. It fits perfect. That's what's happening. And it's the current that's changing all the atoms. And that's making more dipoles, which means that's what's magnetizing it. So you need the current to create the magnetic effect. And it really doesn't have to do with so they think it has something to do with the resistance in the wire. That's what they use in the math. But they're using resistance as a way of describing the capacity to involve atoms. How many atoms do you have? See, obviously if I made a wire really thin, you'd say the resistance is very high by some standard measurement tool. A standard amount of current going through the wire. Obviously the resistance would be very high if it's a little tiny thin wire. If I make a big fat wire, then the resistance is very low, right? Because there's no doubt that you have enough pathway. There's plenty of atoms. So it's not really, resistance isn't really saying what the key function is. The key function is how many atoms do you have. So resistance should sort of be replaced with density of atoms. That's sort of what, so high resistance is low density, Low resistance is high density of available atoms, windows to make transfers through. Right. It's just so it all falls into place. It's game over. I mean, this is this is the right answer, people. This is the proper way to describe mass, momentum, velocity, acceleration, charge, magnetism, voltage, and current. There. This is it. This is the right answer. And you're really dumb if none of you other imbeciles could have figured it out, because it's not that complicated. It really isn't some sort of Chinese weirdo torture thingy. It's not some kind of what was that stupid thing in that stupid movie? Da Vinci Code. You know, it's not some sort of whatever, blah blah blah. You don't need some special, you don't have to do all this crap. It's not that complicated. Sitting here right in front of your face. Alright, enough. So, let's see this. I love this flippy thing. This just charms the shit out of me for some reason. I still have that mailbox sitting over there, covered in dust. Yes, I did starve as an artist, but I starved at everything. Everything I've done, I've starved at doing so. But yeah, can't make a living doing artwork. Horrible. That's on a pillow. I mean, that's, you know, it's painted on a freaking pillow. Come on, that's pretty damn good. Well, that's painted on a box, so that was easy here. Oh, there's this is a good tiger. I like this tiger. Let's see if he flips up here. I really got to paint another one of those. That's really not bad. I like that. Appeals to me. It's a nice. I like it. That one's, see, this one's a little bit off balance. Tones aren't quite right. Shape isn't quite right. It's missing a few things. But anyway, and stuff. But anyway, so until next time. Look compressed for some reason. Really shouldn't be. Well, anyway, I'll fix it some other day. Yeah, that was a good horse I thought too. That wasn't bad. I don't know where the hell that is. Somebody must have taken or bought it. Yeah, I still got that on the wall. Well, it's not a great painting. I just did it for me because I like golf. I like golf courses, so it's just kind of a nice thing. I like it. But anyway, enough of that crap. I do like this. I do like it. I know. It is disappointed. You know, when brilliant people are entertained by, you know, just dirt, simple, stupid stuff, you just say, yeah, it's just no point. Earthlings are such fail. Let's just see if there's anything new to report on. Electric Boom guy, I almost want to unsub from him now. I mean, he's just endless commercials. The whole damn video is commercial. I mean, and he's not saying anything all that damn fucking important or interesting. So anyway, in Piro's, I don't know, he responded to some wacko. He likes to talk to crazy people and do response videos to crazy people. So who could possibly care? Not me. Alright, so enough of that. And we'll move on to the next bit of fun. See, a clock. Another clock. Clocks. Lots of clocks. Alright, so till the next time and such. I think that'll be it.